Okay, good afternoon everyone. So today we'll do some questions on refractive indices. So write down the question. Write down the question. The absolute refractive indices of of two media capital A and capital B are 2.0 and 1.5 respectively, and 1.5 respectively. Full stop. If the speed of light in the medium is when if the speed of a light in a medium B, capital B, is 2 into 10 raised to 8 meter per second, calculate speed of a light in vacuum. Just wait. Sorry, I'm extremely sorry. So write down the question. One more time I will repeat. The absolute refractive indices of two media A and B are 2.0 and 1.5 respectively. Full stop. If the speed of a light in a medium B is 2 into 10 raised to 8. 2 into 10 raised to 8 meter per second. Calculate the speed of a light. Calculate the speed of the light in vacuum and in medium A that we have to calculate. Okay, so what are the given things are given here? So refractive indices of the two mediums. Okay, so here we have a medium A who is having refractive index that is 2.0. Okay, and another medium that is B having a refractive index 1.5. Can you able to see the board? Okay, so these are the two refractive indices are given, and speed of the light in a medium is nothing but 2 into 10 raised to 8 meter per second. Okay, I will write here the speed in the medium B is nothing but we have 2 into 10 raised to 8 meter per second. Okay, and what is the question? They are asking us to find out the speed in the vacuum and speed in the medium A. Okay, so we know that refractive index, absolute refractive index, we have this formula for medium B. We can write NB is equal to speed of a light in the vacuum, divided by, we can write it as speed of a light in medium B. Okay, that is VB. So we have to find out the speed of the light in the vacuum. So this NB we know that is 1.5. So speed of the vacuum I will write VB, and VB is given 2 into 10 raised to 8 meter per second. So speed in the vacuum is nothing but 1.5 into 2 into 10 raised to 8. 15 twos are 30. Point you can adjust. So you will get the answer 3 into 10 raised to 8. Okay, speed in the vacuum is nothing but 3 into 10 raised to 8 meter per second. Okay, this is the answer for the first bit. Okay, copy this much. Then we'll go for the Next, second bit, that is the speed of a light in medium B. Speed of the light in the medium A, that we have to find out. I hope everyone took the screenshot, or those who want to copy, they copied. Okay. So now second part, how to calculate. Okay. Now here, to calculate second part, use the same formula. Okay. Speed of the light in the vacuum, and here it will come speed of the light. Refractive index of A is equal to speed of a light in the vacuum upon speed in medium A. Okay, so we are interested in VA. So write down here VA and adjust this. Speed of a light we just now got 3 into 10 raised to 8 divided by NA is nothing but 2. Okay, 2.0, that is 2. That is nothing but how much? 1.5. So VA we will get it as 1.5 into 10 raised to 8 meter per second. So this is the answer for the second bit. Okay, this kind of questions are very important. They will ask this kind of questions for 3 or 2 marks. Copy this. Getting these problems? Understood how the given quantities are there and how we have to put them into the formula. Okay, so write down one more question. If the refractive index of a glass, if the refractive index of the glass if the refractive index of a glass for a light going from air to glass is 3 by 2 comma, find the refractive index of a air for light going from glass to air. Okay, I'll repeat this question. If the refractive index of the glass for a light going from air to glass is 3 by 2, find the refractive index of air for light going from glass to air. Okay, so here the given things are, I will write here. Check here, these are some different kinds of questions are there. Last year also this kind of questions are mostly asked. Okay, so here refractive index of a glass with respect to air is given. Okay, so how much is given? That is 3 by 2. So we can write here the refractive index and of a glass with respect to air, and this is given 3 by 2. Only this much information we have, and from this they are asking us to find out the refractive index of the air. Okay, light going from glass to air. Okay, so if we want to find out the refractive index, refractive index of a air with respect to glass, then this formula is nothing but 1 upon refractive index of a glass with respect to air, and that value we already have. So you can substitute this value over here, and this value will get it as 2 by 3. Okay, this is what I am getting refractive index for air with respect to glass. Okay, so this is what your answer. Okay, 1 mark question MCQ mostly they are asking. Okay, so in short we can write it here, C glass by C air. Okay, so we are like writing here N glass divided by refractive index of air. This formula can split it like this. Okay, one mark question. We are using principle of reversibility. Okay, because it is traveling from glass to air and air to glass. Okay, so you will get the answer 2 by 3. Okay, simple one mark question. Then after that, write down one more question. Getting this, take a screenshot. Take a screenshot. Okay, write down next question. State the laws of refraction. State the laws of refraction of a light if the speed of light in the vacuum is 3 into 10 raised to 8 meter per second. Vacuum means air also, because speed of light in air is also 3 into 10 raised to 8. So state the laws of refraction of a light if the speed of the light in a vacuum is 3 into 10 raised to 8 meter per second, comma, find the absolute refractive index of a medium in which light travels with speed of 1.4 into 10 raised to 8 meter per second. Okay, so laws of refraction, you know that. So whenever the light is traveling from rarer to denser medium, then that light is what bent towards the normal. Okay, and whenever the ray of light is traveling from the denser to rarer medium, it is traveling away or it is bending away from the normal. This is the first law of refraction. Okay, they are not asking about the reflection, they are asking about the refraction. So refraction takes place when there is a two different mediums are there. So whenever there is a two different mediums are there, suppose here we have a air and here we have a water. Okay, air we can take it as a rarer medium and this is what, a denser medium. So any ray which is traveling from air to denser, then this is nothing but normal, this is incident ray. Whenever it is traveling from one medium to another medium, so rarer to denser, it is always bent towards the normal. Okay, and whenever the ray of light is traveling from denser medium, okay, denser to rarer medium, suppose this is a separating surface, then the ray of light from denser is traveling like this and here we have a normal. In this case, the refracted ray goes away from the normal. Okay, so this is what the first rule, and again we can say that here the incident ray, normal ray, point of incidence, they all are what, lying in the same plane. This is the second rule or law of a refraction. Okay, that theory you can do it, I explained already. And then we have, they are asking us here absolute refractive index. Okay, absolute refractive index of the medium they are asking. Okay, so we know that absolute refractive index is nothing but velocity of a light in a vacuum divided by velocity of a light in the medium. Okay, we have this formula and both values are given. Okay, in vacuum and here that is given. In vacuum it is by default 3 into 10 raised to 8 divided by, in medium how much it is given, 1.4, correct, 1.4 into 10 raised to 8. So 10 raised to 8, 10 raised to 8 get cancelled, remove the decimal, so you will get 30 by 14. Okay, 30 by 14, if you simplify it, that fractional value you will get approximately 2.14. Okay, that is nothing but absolute refractive index of the given medium. That's it. This is also this entire question is asked for 3 marks, 2 marks for explaining and 1 mark is for this problem. Okay, maybe this only question, last numerical, they can ask for 1 mark also in a MCQ. And refractive index is always the unit less quantity. There is a no unit for this. Getting? Can everyone getting? Okay, take a screenshot of this. Then write down one more question. What is meant by what is meant by power of lens, write the SI unit, full stop. A student uses a lens of focal length 40 centimeter and another of minus 20 centimeter Write the nature and power of each lens. Okay, so I'll repeat this question. What is meant by power of lens? Write the SI unit. A student uses a lens of focal length 40 centimeter and another of minus 20 centimeter. Write the nature and power of the lens. Okay, so first part of this question is a theory part. They are asking here, what do you mean by power of lens? Okay, so what do you mean by power of lens? Power of lens is nothing but ability to converge or diverge of a light rays passing through it. Okay, or else we are writing power of lens P is nothing but reciprocal of the focal length. Okay, so here can we write the reciprocal, means we can write here ability, or we can write here power P is nothing but 1 by F. Okay, so you can define power is also reciprocal of the focal length. P is equal to 1 by F. So this is what the definition. So here they are saying write the SI unit. What is the SI unit? SI unit of a power. So focal length is actually measured in terms of meters. Okay, and P we are measuring in terms of diopter. Okay, that we are writing it as a diopter D. It is denoted by letter capital D. DIOPTRE. PTRE. So this is what diopter. Okay, so this is SI unit, and then they are asking a student uses a lens of focal length 40 centimeter and another is minus 20 centimeter. Write the nature and power of each lens. Okay, so first lens is nothing but 40 centimeter. Okay, so I will write first lens. Focal length is given now. Focal length is 20 centimeter. So we are writing in terms of meters. So 20 divided by 100. So power we have to calculate. So we will calculate power. So P is equal to 1 by F1. Okay. So first lens is given 20 first lens whose focal length is given 20 centimeter. So we can write 1 by F1. So 1 upon, you can write 20 divided by 100. That is nothing but 100 divided by 20. That is nothing but plus 5 diopter. This is nothing but what? Your power of lens. for the first lens. Getting this? These kind of questions are coming. It is 20. Oh, sorry. Focal length of a first is given 40, not 20. Sorry from my end. Okay, 40. I thought it is 20. Okay, 40. Then here also it comes 40. 40 means plus 2.5. Okay, 40 is nothing but 2.5 diopter. Okay, this is what the answer for first power of lens. Can you getting this? Okay, copied everyone. So they are in there only. They are asking second one. Second lens is nothing but yeah, it is minus 20. No, so yeah, even they are asking nature for both. So as the lens is here, power we are getting positive and focal length is also given positive. So this is nothing but what? Converging lens, or we can say that it is a convex lens. This is what? Convex or converging lens. Okay, so this is what the first part. Okay, so then we'll go for the second part. In second part they are saying focal length is given how much? 20 minus 20 centimeter. So we can write minus 20 divided by 100 meter. So power P is nothing but 1 by F. That is nothing but minus 100 by 20. So P is nothing but what? Minus 5. Minus 5 diopter. As here power is nothing but negative, that means this is nothing but what? Concave or diverging lens. Okay, so this is nothing but what? Your question. This total question is asked for 3 marks. 1 mark is for definition for lens, power of lens, and 1 mark is for first bit, and another mark is for last bit. Can you getting this? Can you? Okay, then write down one more question. Write down. Yeah. Here write down the refractive indices. The refractive indices of a glass. The refractive indices of a glass and water with respect to air are 3 by 2 and 4 by 3. 3 by 2 and 4 by 3 respectively, full stop. If speed of a light in a glass is 2 into 10 raised to 8 meter per second, find the speed of a light in a water. Find the speed of a light in the water. Okay, so I'll repeat this. The refractive indices of a glass and water with respect to air are 3 by 2 and 4 by 3 respectively. If if speed of a light in a glass is 2 into 10 raised to 8 meter per second, find the speed of the light in the water. Okay, that we have to find out here. So again, this is total 2 mark question. Okay, so here first refractive index is given, refractive index of a glass and water. Okay, with respect to air it is given. Okay, so we can write it down. How to write down this? That is, learn this how to write down the given quantities in the whenever the refractive indices are given. Okay, so देखो how to write this. So very first part they are saying here, the refractive index of a glass with respect to air. Okay, air by glass, can we write here? Air by glass is given, that is nothing but 3 by 2, correct? That is nothing but 3 by 2. This is first thing. Okay, then after that they are saying air to water, that is 4 by 3. Air to water, it is nothing but 4 by 3. This is given. This much is given, and even they are saying the the speed of a light in the glass, that is Vg, given 2 into 10 raised to 8. Okay, Vg is given 2 into 10 raised to 8 meter per second. So these are the given things with us, and they are asking us to calculate, find the speed of a light in the water. Okay, that we have to calculate now. So how to calculate the answer for this? So first you can find out the refractive index of the medium. Okay, so how to calculate the refractive index of a medium? So refractive index of medium is equal to what? Speed of a light. Okay, which speed of a light you are taking now here? You have to take speed of a light in the air. Speed of light in air divided by speed of a light in a medium. Okay, so from this you will get the values. So substitute here, the refractive index of the medium is nothing but what? 3 by 2. Okay, and then we know here glass ka velocity means speed, we know that in the glass. So here refractive index of the medium means we have to take refractive index of the glass, so that we will get the speed of the light in the air. Okay, so here I will adjust the formula. Velocity of a light in the air, I will write it as a VA. So this term you can transpose and multiply. Refractive index of the medium is nothing but 3 by 2, and speed of a light in the medium is given Vg, that is 2 into 10 raised to 8 meter per second. 2 and 2 get cancelled, and we will get the answer 3 into 10 raised to 8 meter per second. So this is the answer for velocity of a light in the air. Okay, 3 into 10 raised to 8 meter per second. Don't forget to write the units. Okay, so now the second part is what? They are asking speed of the light in the water. We have to calculate. So similarly, same formula you can use. Speed of a light in the water is nothing but refractive index of a water. Air to water is given 4 by 3, and refractive index then multiplied by velocity of a light, that is 3 into 10 raised to 8. So here 3 get cancelled, and we will get 4 into 10 raised to 8 meter per second. So this is what the answer we are getting. So this is 2-mark question. Yes, copied. Take a screenshot. If you have any doubt, you can ask me. Here we have to calculate the speed of the water, I wrote directly, no, sorry. We have to divide here, because speed of the light in the air will go and divide here, no. Okay, sorry. Wait, don't, you can take it here 4 by 3, and this should be divided by 3 into 10 raised to 8. Okay, so this will come 4 by 3, 9. So 9, if we do this, we will get something 2.25 into, yeah, 4 by 9, that is 9 into 9 by 3 into 10 raised to 8 we are getting, and this is nothing but 2.2 something into 10 raised to 8 meter per second. This is what the answer we are getting. Okay, so copy this and check once. Okay, copied. Then write down next one. So next one you can try yourself. Write down. Yeah, write down the absolute refractive index of a ruby. You can write down absolute refractive index of a ruby. Just wait. Refractive index of a ruby is 1.7. Find the speed of a light in the ruby. Find the speed of the light in the ruby. The absolute refractive index of a ruby is 1.7. Find the speed of a light in the ruby. Full stop. The speed of the light in the vacuum is 3 into 10 raised to 8 meter per second. Okay. So find out that. Can you able to see the screen now? It's better. Okay, find out the answer. What is the answer for this? Absolute refractive index of the ruby is 1.7. Find the speed of a light in the ruby. The speed of a light in vacuum is 3 into 10 raised to 8 meter per second. Calculate this. Check. Try this question. Write down the formula first. Those who got the answer 17.76, their answer is correct. Refractive index is nothing but what? Speed of the light in an air or vacuum to the speed of the light in a medium. Okay. So here write down mu is nothing but, or refractive index is nothing but speed of a light in vacuum upon speed of a light of a light in medium. Okay, so these values are given. Okay, so C is nothing but velocity of a light in a vacuum is nothing but 3 into 10 raised to 8. Okay, and the refractive index of the ruby is given. So we have to find out the speed of a light in the medium. So transpose this. Speed of the light in the medium is Vm is nothing but C. This is velocity of a light C and refractive index of a ruby. I can write it as Nr. Okay. So we can write it as here. We can substitute the values. So that C is nothing but what here? 3 into 10 raised to 8 divided by refractive index of the ruby is given 1.7. Okay, 1.7. Do this multiplication and division. We'll get 17.76 into 10 raised to 8 meter per second. Okay, this is the answer. Okay, so this kind of 1-2 marks problem they used to ask. Okay, write down one more question. Can you able to see the board properly? Okay, then write down next question. Write down the power of lens is plus 5 diopter. The power of lens is plus 5 diopter. What is the nature and focal length? What is the nature and focal length of this lens? Of this lens? Question mark. At what distance? At what distance from the lens? From this lens should an object be placed so as to get its inverted image, of the same size, Okay, so I will repeat this. The power of a lens is plus 5 diopter. What is the nature and focal length of this lens? At what distance from this lens should an object be placed so as to get its inverted image for the same? Okay, so here power of the lens is given. Okay, so power of the lens is given, that is also plus. Okay, plus 5 diopter given. Plus 5 diopter. I will write power of a lens is nothing but plus 5 diopter. This is nothing but given. Okay, from this we have to calculate the focal length. Okay, so first write down the basic formula. P is equal to 1 by F. Therefore F is equal to 1 by P, and 1 by P is nothing but what? 5 diopter. Okay, but we are not keeping 5, no? We are converting this diopter into centimeter. So how to convert this? 5 divided by 100 meter. So here 5 and 100 goes up. So here we will get 20 centimeter. 20 centimeter is the focal length. Okay, 5 diopter, that is 20 centimeter we are getting. So we are getting the answer here. Focal length is positive, as power is also given positive. Then nature is nothing but what? We are having convex lens, or we can say that it is nothing but what? The converging lens or converging lens. Can you getting this? Okay, so now this is what one part of this question is over. So they are asking at what distance from this lens should an object be placed so that we will get inverted image of the same size. Okay, if you check the lens, that in NCERT textbook we have that table. Okay, so we will get inverted image of the object. Okay, inverted image of the object, but that image should be of same size. Okay, so in that case we will get the exact height of the image when the image is at focus, when the it is at center. Okay, so here distance, that is from the lens we have from the center, means on the center, and that should be how much here? This is focal length is 20 and double of focal length is nothing but center, that is nothing but 40 centimeter from the lens we can keep. Okay, at the center or on the center we are keeping that. Okay, this is the answer. Getting this? Copy this. Then write down one more question. A figure shows a ray of light. A figure shows a ray of light a figure shows a ray of light as it travels from medium A to medium B. Medium A to medium B. Medium A to medium B. Refractive index of the medium B relative to medium A is options are given. First option √3 by √2. First option is given √3 by √2. Second option given, that is √2 by √3. Third option is given 1 by √2, and last option is given √2. Okay, these are the option, and even figure is also given here. Those who know how to apply the trigonometry, okay, they can easily solve this question. Okay, and here the figure is given. This is 45, this is also 45 degrees incident ray. Okay, and it is refracted. Okay, and then here this is given 60. Okay, this is given 30. Observation should be here, observation is must. Okay, so ray of light is traveling from, this is medium B, this is medium A. So ray of light is traveling from A to B only, A and B. Okay, this is what the figure given. So the figure shows the ray of light as it travels from medium A to medium B and having refractive index of the medium B below relative to the medium A. Okay. So now if you observe this diagram, see what they are asking, that is afterwards we can think. The ray of light is traveling from A to B. Okay. So this line is nothing but what? Normal, and this is also what? The normal. Okay. So here this angle is not included. This angle is very important because this line angle making an angle with normal. So this is angle of incidence, we are getting 60. Many kids are taking this. This angle is not necessary to take. We are measuring the angle of incidence and angle of refraction with respect to the normal only. Okay. So normal only. So angle of eye is equal to 60 and it is traveling from A to B. So refraction is there. Angle R is nothing but what here? It is making with normal, that is equal to 45. So here refraction takes place, not reflection. Chalo, reflection is there, then angle of eye is equal to angle of R we are writing. But here not a reflection, it is a refraction. So we have to apply the first law of refraction, that is the Snell's law. So what Snell's law says, that refractive index or any constant is equal to sine of I by sine of R. So sine of I is nothing but how much? 60 and sine how much? 45. Okay, now substitute the value. You know that sine 60 is nothing but what? Root 3 by 2. Okay, sine 60 is nothing but root 3 by 2 and sine 45 is nothing but what? 1 by root 2. If you simplify this, then you will get the answer root 3 by root 2. Okay, root 3 by root 2. Getting? You know the simplification, no? 3 by 2 into root 2 by 1. Okay, so you can simplify this and then you will get the answer. Okay. So here you can write it as root 6 by 2. Okay. So this 2 we are writing it as a, here we can write 3 into root 2 divided by root 2 into root 2. Okay. And then you can write it as root 3 into 2 by 2 into 1 by root 2. 2 get cancelled and we can write here root 3 by root 2. Getting this? So this is what the simplification. Sometimes this question they can ask for the 2 marks also. Okay, because we have some mathematical calculations over here. Copy this much or take a screenshot. Okay, write down one more question. I hope everyone is getting this. Okay, so write down next question. The diagram below, given below, write down the questions. The diagram given below shows an object O. Shows the diagram given below shows an object O and its image I. Its image I without actually drawing the ray diagram without actually drawing the ray diagram, state the following. First bit, write down type of lens. First bit, type of lens. Second, name two optical instruments. Where such an image is obtained. Third bit, list the characteristics of image formed if this lens is replaced by concave mirror of focal length f focal length f and an object is placed at a distance f by 2 in front of the mirror, f by 2 in front of the mirror. Okay, so here I'll repeat one more time. The diagram given below shows an object O and image I. Without actually drawing the ray diagram, state the following. First, type of lens. Second, name two optical instruments where such an image is obtained. Third, list three characteristics of the image formed if this lens is replaced by concave mirror of focal length f and object is placed at a distance of f by 2 in front of the mirror. Okay, so actually here diagram is given. Okay, but that is for reference, but we don't have to draw any ray diagram. We have to guess and write the answers. Okay, so this kind of questions can also come for 3 marks. Okay, so here the diagram is given. Then this is what optical center they gave. This is the object. Okay, and they mention it as a O. This is F. This is twice F. Okay, and here the image is formed beyond the center. Okay, this is what image. So from this at least you should know image object height is smaller than the image. Image is here magnified. Okay, this is we have a convex lens. Okay, so here they are asking from this which kind of lens it is. Okay, type of lens. This is which lens is there? Converging lens. Okay, we have here converging. First answer we will get converging lens. Okay, and second they are asking name the two optical instrument where such images are obtained. So object is small, image we got a magnified. So where we are using this kind of lenses? In microscope, because a very small particles, okay, which we cannot see with our naked eyes, so that we can find it out by using microscope. That is first, even the planets or the stars which are very far from us and we can observe them from the telescope. So there also we are using these lenses. So second, in short they are asking what are the uses actually where we have this application. So first it will come in microscope and second you will get telescope. Okay, so third, now it's very important, third one, list three characteristics. So here first one it is given. First is what? Magnified image. We will get, this is not a real image, no, this is what we are getting, virtual image. Okay, then as well as we can say that we are getting this behind the mirror. Behind the mirror. So these are the three characteristics we are getting, okay, from this ray diagram. Very important and very easy. If you know all the concepts, then only you can feel it is easier. Copy this or take a screenshot. Finished? Is everyone copied? Okay. So one more last question we are doing. So with this I finished entire numericals from this chapter. Okay. So tomorrow onwards I will take other chapter from the science. Okay. So write down next one. Refractive index of a water. Refractive index of a water with respect to air. With respect to air is 1.33 and that of diamond is 2.42 and that of diamond is 2.42. Okay, first bit, in which medium does the light move faster? In which medium does the light move faster, comma, water or diamond? Water or diamond? Water or diamond, question mark. Second bit, what is the refractive index of diamond with respect to water? What is the refractive index of a diamond with respect to water? Okay, so all the tables, refractive index table and speed table is given in NCERT textbook, but still refractive index is nothing but what? I will write the formula again. Okay, it's very important. If you know the formula, then you can write or you can give the answer for this. Okay, so we can write here refractive index is nothing but speed of a light in air to the speed of a light in medium. Air is nothing but what? Vacuum also. VV also you can write. Okay. So refractive index based on these two ratios of refractive index ratio of velocity of a light in the air and to the velocity of a light in the medium. Okay. So if you have a textbook with you, just check. Refractive index of a diamond is always greater. Okay, its refractive index of the diamond is greater. If you have, check a last bit from that table is diamond. Okay, so refractive index of the diamond is more than speed of the light which is traveling into the diamond is less. Speed in diamond is what? Less, because here there is what? Inverse proportion. Refractive index is inversely proportional to the speed of a light in the medium. Okay, as refractive index is more for the diamond, then velocity of the light in that diamond is what? Very less. Okay, so like that we have to answer. Okay, so here diamond is that is given 2.42, that refractive index is more. So that means velocity is what here? Less. But they are saying here given velocity, the speed of the light in the water is given, that is refractive index of a water is given 1.33. Okay, so here they are asking first, in which medium does the light move faster, water or diamond? Of course, now here refractive index, I will write here, refractive index of a water is given smaller. Okay, smaller than the diamond. Okay, so as I told you, refractive index is inversely proportional to the speed of a light in the medium. So here less is the refractive index, speed is more. So here we can say that velocity in the air is greater than the velocity in the diamond. Velocity of light in the diamond. So this is what the answer of first bit. Okay. Now second bit, what is the refractive index of a diamond with respect to the water? With respect to water they are asking. So refractive index is nothing but we can write it as refractive index. Refractive index of a diamond to the refractive index of a water. Okay, this you have to write. Okay, and find out the answer. Okay, so we have here refractive index of a diamond is given 2.42, no? 2.42 upon 1.33. Okay, so find out this, do the calculation, check how much is the answer you are getting.
बैठो
अरे सांगना त्याला गप्प बस म्हणून. So check the answer how much it will come. If you calculate, you will get here 1.82 is a refractive index or absolute refractive index of this. Okay. So these are the probable questions. These are the probable questions from this chapter. Okay. I covered almost all the numericals from this chapter. Check once and go through all the questions once again. Tomorrow I will take another chapter. Okay. So I'll end this session.